Okay, guys, let me go to the programming through problem solving. Uh, yes, where am exactly? DBATU first year engineering. Is it visible? Visible? Huh? Visible है क्या? Huh? So programming for problem solving, and today we shall see about today we shall see about uh, programming for problem solving. Programming for problem solving. Okay. Now it's a time to start. Create a C program to perform bitwise operations on integer variables and print the results. Okay. So in the last sessions we learned about third experiment and fifth experiment. Today we shall see about bitwise operations in C programming. Okay. Fine. So create a C program to perform bitwise operations on integer variables and print the results. So as of our knowledge in C programming, we have 6 types of bitwise operators, or you can also call as bit operators, and they work actually they work on a bit level, so that's what they are called as bitwise operations. Okay, bitwise operators. So in the arithmetic logic unit, this arithmetic logic unit, which is a part of CPU, central processing unit, it performs mathematical operations like addition, subtraction, multiplication, and divisions, and those operations are done on a bit level. You can call ones and zeros. So those ones and zeros operations need to be performed with respect to bitwise operations. Okay, like bitwise and, or, not, XOR, complement, left shift, and right shift. So let's see one by one. First operator is bitwise AND. What bitwise AND does in C, it takes two numbers to perform bitwise AND operations as operands and does AND operations on every bits of that numbers of that both numbers. The result of AND is only one. AND is one only if both the bits are one. So let's see the truth table. So this is the truth table of a truth table this is the truth table of bitwise AND. So I have A, bitwise A, bitwise B, and A and B. So 0 and 0, you will get 0. 0 and 1, you will get 0 output. 1 and 0, you will get 0 output. If both bits are 1, then only you will get the output as a 1. So you can call this is the input and this is what? Output. So these two are bitwise A and bit B are inputs, whereas A and B will give you the outputs. So bitwise AND operator is a single ampersand. What is the symbol for this? It's a ampersand. It is just a representation of AND, which does it works on the bits of the operands rather than the truth value of the operands. Bitwise binary AND performs logical conjunction. As I shown in this table, it performs logical conjunction operations of the bits each position of a number in its binary forms. Let's see an example of a bitwise AND operations. Okay, so this is my 12 in decimal number. So 12 in, let me write in decimal, 12 in bracket in decimal, okay, 12 in decimal, and its equivalent in binary is 4 times 0 double 1 double 0. Similarly 25 in decimal, and 3 times 0 double 1 double 0 1 in binary. Okay, for 25. If we perform bitwise AND operation, bit operation bitwise AND operations of 12, let me write here comma instead of writing ampersand. So here I wrote the 12th binary. Here I wrote what? 25th binary, 25th binary. And if you perform bitwise AND operation, you will get 000 100, which is equal to decimal in 8. So you'll get output bitwise 12 to bitwise 12 bitwise and 25 is 8 in decimal, or in binaries 000 or 4 times 0 100. Okay, let's see about bitwise OR operations. So actually bitwise OR operation is just exactly reverse of a bitwise AND operations. So bitwise OR operation symbol is a pipe. So already we learned in the class same. So bitwise OR, in C, it takes two numbers as operands and does OR on every bit of two numbers. The result of OR is 1 if any one of the two bits is 1. Okay, let's look at the truth table. So here is truth table of bitwise OR. Okay, so I have bit A, similarly I have bit B, and here I'm performing bitwise A or B. Okay, and this will be the output. So let me scroll up. Okay, I think I scrolled down too much. So if you give the 0 and 0 or 0, obviously you will get the 0 as output. If you give 0 and 1, sorry, 0 or 1, you will get output as a 1. If you get 1 or 0, you will get output as a 1. If you pass 1 or 1, you will get a 1 as the output. Similar to bitwise and, bitwise OR performs disjunction, logical disjunction operation at the bit level, whereas bitwise AND operation performs logical conjunction. Bitwise OR performs logical disjunctions on the bit level. So it is a result is a 1 if either of the bits is 1 and 0 only when both bits are 0. Its symbol is what? Vertical pipe. Okay, vertical pipe. This is a symbol. Fine. So 12 in decimal and 25th in decimal. Those decimal numbers are counted into binaries. Okay, these are the two binaries on the right hand side of the assignment operator, and left hand side is decimal. Let's perform a bitwise OR operation on 12 and 25. So binary convert into binary and OR operations. If you convert into OR operation, you will get 0001 1101, which is equivalent in decimal is 29. Okay. So let's see an XOR operations. So bitwise XOR, in C, it takes two numbers as operands or values or numbers and does XOR on every bit of the two numbers. Okay, the result of XOR is 1 if two bits are different. Two bits are different means either 1 or 0 or 0 or 1. Okay, so here you will find what? So bitwise XOR truth. Let me add here truth table. Okay, so bit A, bit B, A XOR B. So 0 or 0, 0 XOR 0, both bits are same, you will get 0. Now here 0 or 1, both bits are different. Both bits are different, 0 or 1. You will get what? 1. Next 1 or 1 XOR 0, both bits are different, you will get 1. Both bits are same, 1 XOR 1, you will get 0. Okay, so this is the truth table for bitwise XOR. So bitwise XOR performs an exclusive disjunctions, which is equivalent to the adding two bits and discarding the carry. The result is 0 only when we have two zeros or two ones. XOR can be used to toggle the bits between ones and zeros. Thus, I assignment operator I XOR 1 when used in loop toggles its values between 1 or 0. So let's see an example of a bitwise XOR. So 12 in decimal and 25th in binary, and opposite side of the assignment operator, that is RHS. Those are binaries and decimal values of 25 and 12. Let's perform bitwise XOR operations on 12 and 25. So the binary of a 12 is 000 4 times 0 11. Binaries of a 25 is 000 11 001. So if you perform the bitwise XOR, you will get 21 in decimal, and in binary you will get 000 Okay, let's see one more operator in bitwise, that is left shift. Similar to left shift, you will find right shift also, but first see left shift. In left shift in C programming, it takes two numbers or two operands. The left shift the bits of the first operands. It shifts the left bits of the first operand, and the second operand decides the number of locations or number of bits or number of places to be shifted. So left shift operator shifts all the bits toward the left by a certain number of specified bits. The bits position that have been vacated by the left shift operator are filled with the zeros or filled with the zeros. So let me write here zeros. Okay. The symbol of the left shift operator is less than. Okay. So 2 212, its equivalent in decimal, it's a 212 is in decimal, and its binary is 1101 0100 in binary. Okay, so how it converts? So what I'm doing here, so I'll let you know first how it works actually. So let me shift this example in an easy way, a practical way, so that you will get the idea. So 212 to be shifted to where? uh, Left. Okay, means this should be shifted one place to the left. Okay, so let me give you practical implementation. So I'm shifting one. So first let me give the number one. Oh, one. I'll give the space first so that we'll get the idea. It's better. Two, three, four, five, six, seven, eight, nine. Okay. Hmm. How come nine? It should be eight. It should be eight digit, right? Double one zero one zero one double zero, right? Now these bits I'm shifting, not one place, but I will shift to now two places. Okay. So here two places means what will happen? So let me write the two places to this location. Okay. Fine. What I'll do now? These two places will be shifted to where? Here. So let me shift here. Okay. This will be shifted to here now. Means what? So here at the zeroth place, uh, at the eighth place will come 0, at the seventh place will come 0. Okay, at the sixth place you will get 1, at the fifth place you will get 0, at the fourth place you will get 1, at the third place you will get 0, at the second place you will get 1, at the first place you will get 1. Okay, and these ninth position and 10th position will be filled with what? Can you give me the answer? These empty two field, what are the shifted field, shifted locations, shifted bits will be filled with the, please give me the answer. Zero. Good, very good. These empty location will be filled with the zero. Look at here, only I told you, the bit position that have been vacated by the left shift operator are filled with the zeros, right? Okay, already I have made this statement. So what should I write here? 0 and 0. Okay, and this number will become, so, and then convert this number to what? Decimal, and this decimal number will be printed. Clear now? Clear? Similarly, if you left shift by 1, you will get in binary this value. If you left shift by 0, left shift by 0 means what? Left shift by 0 means what? No shifting. No shifting, na? Left shift by 4, the 4 digits will be displayed. So 4 digits will be shifted, okay? So if you perform left shift on the any number, any integer number, that small number will become large number. That small number will become large number, okay? Similar to left shift, we have a right shift operator. So the right shift operator in say it takes two numbers or two values or two operands, okay? The right shift, it right shifts the bits of the first operands, and the second operand decides the number of places to be shifted at the right side. Number of places to be shifted at the right side. Okay. So I will take same example for your understanding sake so that you will have the clear idea. Okay, 212 in binary. So I'll shift this number to the second places. Okay. So I'll take this same. Where is that number? Okay, fine. I'll take this one same, and instead of this left shift, I'll do? I'll perform right shift. I'll change the symbol from left shift to what? Right shift. Okay, right shift. Now it will be shifting to where? Right side. One, wait, one, two. Okay, 2 bits, sir. And the number will start from third. One, one. Okay. The next 0, 1, 1, 0, 1, 0, 1. And these 0 and 0, these two zeros and 0 will be what? Will be in a garbage. These two values will be in a garbage. Okay, will be removed. Will be vanished. So I'm removing. I'm what doing? What I'm doing here? I'm removing. So these last two numbers will be what? Vanished and lapsed. So if you perform left shift, you will get value as a you will get value this form. Similarly, you can perform right shift with the 7, right shift with the 8, right shift with the 0. Okay. So this is about right shift operator. Next, let's see the bitwise not, or you can call complement. Bitwise not, or you can call complement. So let me write here complement. Okay, complement. In C, in C programming, bitwise complement or bitwise not takes only one operand or only one number, and it inverts or negates all the bits of it. Okay, and the bitwise complement operator is a unary operator. Is a what? Unary operator. Bitwise and, bitwise or, bitwise XOR, left shift and right shift. All these five operators were binary operators. Which operators? Binary operator. Whereas bitwise complement, or you can call bitwise not, is a unary operator, similar to increment and decrement. Right? Okay. So, bitwise complement operator is an unary operator. It works only with the one operands, and it inverts the bits. Means what? Invert the bits means what? It changes ones to 0 and zeros to 1. Okay, and it is denoted by what? Which symbol? Tilde. It is called as what? Tilde. Repeat along with me, all of you, all boys and girls. It is called as what? Tilde. Okay. Let's have an example. I have 35 number. Okay, and its binaries. So this is in decimal. So let me write in decimal. Okay. So bitwise complement operation of 35. So I perform binary and it's complemented. 0 becomes 1, 0 becomes 1, 1 becomes 0, triple 0 becomes what? Triple 1. Okay. And double 1 becomes what? Double 1 becomes what? Santosh. Navnath. काय चाललंय? Double 1 becomes what? Double 0, because it's inverting na. So this 35 becomes what? 220 in decimal. So let's see an example. So Control C. Let me open the dev. Dev. Okay, guys. Let's see now. So that you will have the idea. Leave it. I am not writing the results. I don't want to write results here. Simply, I want to print all the values. Okay. All the program to be shown on the single page. Okay, fine. It is visible now. So let me save here. Let me add one more line because I have changed some part of APIs libraries. So let me add here conio.h and let me hold the value into where uh, let me get hold the console. So let me save and here what bitwise example 1 and here C source file. Okay, let me compile now. Control X. Okay, guys, fine. So compile, execute, compile, done. Let me run. Look at here. Somewhere I have passed a variable, okay, as an operand, complement of A, right? At line number 13. So complement of A becomes 4 to 9496667 So let's see. First, let's see, guys. First, what is A value? 5 and B value is what? 9. Okay. A and B. If you perform A and B, you get 1. So I got somewhat wrong results. Actually, you will get different results based on compiler to compiler. Okay, 16-bit compiler, 32-bit compiler, 8-bit compiler, or 64-bit compiler. Okay, so 1 and B, 5 and 9 is 1. A or B is 13. A XOR B is 12. Complement of A is 4294967290. Output, instead of giving the output, let me give what? Output of what? Complement of 35. What is the complement? 35. Okay. And here what? Output of complement of or not of tilde, not of minus 12. Okay. And here what? Okay. Here only left, directly left shift. Here is what? Right shift. Fine. Uh, Control F9. Compile done. Control F10. So guys, output of complement of 35 is minus 36. Output of complement of minus 12 is plus 11. Okay. B left shift 1. B left shift 1 means what? 9 left shift of 1, 18. And 9 right shift of 1 is what? 4. Clear all of you? All of you clear? Okay. So guys, let me add the output here. Uh, Control F10. So what I'll do, I will write the output here. So this is what you have to write the output in your file, journal files. Okay, PPS journal file. You have to write the output. You have to write the program. You have to write this explanation also. So output is you can convert the same program. So I took static inputs. What I did here, I took here static inputs. So I suggest you to work on the dynamic inputs by using scanf. By using what? Scanf. Okay. Okay, guys. Fine. So what I used here. So here, this is the theory. This is the theory, and this is what? Software tools. What I use? Dev, Dev CPP is what? IDE. Okay, and here where I use a GCC compiler. Okay, GCC compiler or C language compiler and text editor you can call. Okay, fine, guys. So done. Next, after this, we shall see about control flow statements. Okay, fine. Thank you.